Welcome. In this lesson, we'll cover the reasoning strategies that turn a one-shot language model into a goal-directed agent. We'll look at chain of thought, react, and task decomposition, and how to make each one reliable in production. A plain language model gives a single answer to a prompt. But an agent must pursue goals that span many steps, call tools, and adapt when reality differs from its expectations. Reasoning patterns are the scaffolding that turns a single prediction into a controllable process. We'll focus on 3: chain of thought, react, and decomposition. Chain of thought asks the model to produce intermediate reasoning steps instead of jumping to an answer. You can trigger it zero shot with a cue like "let's think step by step," or few shot by showing worked examples. COD is purely internal reasoning, no tools involved, so it's cheap and improves accuracy on math and logic, but it can't reach out to the world for fresh data. React interleaves reasoning with acting. Each cycle has a thought about what to do, an action that calls a tool, and an observation containing the result. That observation feeds back into the next thought. Because the model checks its assumptions against real tool output, React grounds reasoning and reduces hallucination. Here's the skeleton. We loop until the model gives a final answer or we hit a step limit. Inside, the model returns either a final answer or a tool action. We execute the tool and append the result to history. In production, use the provider's structured tool calling API rather than parsing free text, truncate long observations, and always set a max step limit to bound cost and prevent infinite loops. For complex goals, have the model plan first, produce an ordered list of subtasks with dependencies, then execute them. Plan and execute generates the whole plan up front, which is cheap and predictable. Interleaved planning replans after each step, which is adaptive but costly. A practical hybrid generates a course plan, executes it, and only replans when a step fails or an observation contradicts the plan. Good decomposition follows a few rules. Each subtask should be independently verifiable and map to a single tool or clear action. Capture dependencies so steps run in the right order. And keep subtasks atomic. If a step is itself complex, recurse and break it down further. This makes the plan easy to debug and even parallelize. How do you choose? Pure logic or math with no external data calls for chain of thought. Tasks needing live data and adaptation call for React. Long multi-stage workflows benefit from plan and execute with replanning. In practice, mature agents combine all three. A planner decomposes the goal, each subtask runs a React loop, and the internal steps use chain of thought reasoning. Finally, production reliability. Bound everything, max steps, max tokens, and per tool timeouts. Validate structured outputs against a schema and retry on parse failure. Trace every step including thought, action, arguments, observation, latency, and cost. These traces are your primary debugging tool. Detect when the agent repeats the same action to break loops, and always fail gracefully with partial results and a clear reason.